Okay. Recent years, ozone in the stratosphere has been depleted at very fast rates because of chlorofluorocarbon decompositions. The chlorofluorocarbons, such as CFCl3, is first decomposed by this reaction. Then the chlorine radical from here undergoes this reaction to deplete the ozone. We're asked to write the overall reaction for the last two steps. So you can see this disappears, and this disappears, so I end up with O3 plus O yields, whoops, and I could write 2O2, but I'm going to write O2 plus O2. Next, what are the roles of Cl and ClO? Cl is a catalyst and this is because it's present as an initial reactant and as a final product. The ClO is an intermediate because it's present as first a reactant, or first a product, then a reactant. C. Why is the fluorine radical not important? To this mechanism? And this is, I don't know if the answer is actually so simple. Okay, let me see my reactions here. Okay, so the CF bond is much stronger than the CCl bond. And that is because fluorine has a higher electronegativity than chlorine. Thus, the Cl radical will form, but the fluorine stays bonded to the carbon. And finally, D. I think it's finally, I don't know, I shouldn't say finally. Nope. One suggestion is to add hydrocarbons to ethane. Will this work? Suggestion to reduce the concentration of the chlorine radicals is to add hydrocarbons. Such as ethane to the stratosphere. Will this work? How will this work? If we add, let's see what happens in this reaction. Let me write it down. See if I can think of what's going to happen here. Okay, so that will bond. It'll create an HCl plus C2H5, which, just gives us like more acid up there. That's probably not too fabulous. And then we're going to draw potential energy versus reaction progress. For the uncatalyzed, O3, O plus 2, or yields 2O2. And then we're going to use thermodynamic data to figure out if this is my uncatalyzed. Let me read this whole thing. Potential catalyzed and uncatalyzed. Uncatalyzed and catalyzed. Okay, so I was wondering why I was just doing one. Here's our uncatalyzed. And here will be our O3. And then I'll have to figure out what this is. And then for my other one, I'm going to have about the same spot here, and then about the same spot here. But I'm going to have one and then another. This is O3 plus O plus Cl. This is ClO. And ClO and O2 and O. And then I have 2O2 and Cl. Okay, so this is my first activation energy. This is my second activation energy. And this again is my heat of reaction. And then we're going to figure out our heats of reaction. So my delta H for the reaction will be figured out by taking the sum of our reactants. So it'll be 0, 2 times 0, for my products. Then we're going to subtract from that 1 times what's O3? 142.2. And then we'll add to that 1 times 249.4. And I will get my delta H for my reaction is equal to negative 391.6 kilojoules per mole. So that's this value right here, negative 391.6 kilojoules per mole. So this is exothermic. And I think that's all I can think of to write down on this one.